So हम लोग पाइथन मेमोरी मैनेजमेंट पढ़ रहे थे. We have already covered till point number 8, functional arguments वाला जो point था. And to give a brief about what we covered in the previous video was the concept that how everything is stored in Python. Everything is an object. Variable references were covered, assignment, mutability, immutability, and some examples, very insightful examples we covered. So now creating copies. So whenever we want to create a replica, for example, इस एग्जाम्पल के लिए तो फिर एक लिस्ट दिया हुआ है 1 2 3 and there are 3 statements given to us. All these 3 statements are a method through which we could copy a list. So basically original, so this is an object, ठीक है, everything is an object in Python. So 1 2 3 is an object of type list and it's stored in some memory address, let's say A1, and एक name है original which is referencing to it. So this is the initial setup. Now someone says that I have to create a copy of it. So ये जो 3 मेथड दिए हो इनसे we create shallow copy. So basically original.copy या फिर original, and this syntax particularly, it is a way to slice from a list. So basically इस list का 1 2 3, so basically ये जो syntax होता है इसमें 3 प्लेस होल्डर्स होते हैं. फर्स्ट वुड बी द स्टार्ट इंडेक्स, the end index, the end, and the step. So basically अगर if someone is writing just this, इसका मतलब by default start में 0 आ जाता है, end में length आ जाता है जो भी लिस्ट का है, और क्योंकि लास्ट वाला हम लोग काउंट नहीं करते, इट्स नॉट इंक्लूसिव, ठीक है, एंड स्टेप साइज 1 आ जाता है. तो दिस अगर हम लोग जीरोथ इंडेक्स जो कि ये 0 1 2 जीरोथ इंडेक्स से लेंथ तक जाएंगे, मतलब लेंथ से जस्ट पहले, तो लेंथ 3 है तो जस्ट 2 तक जाएंगे, तो वी कवर द होल लिस्ट विद अ स्टेप साइज ऑफ 1. ठीक है, तो zeroth index is covered, first index is covered, and second index is covered. So this syntax is basically slicing, ठीक है, the whole array for your list. Fine. So this is also a way through which we could create a shallow copy, and the third is using the list method. Okay. So there is an original list which is this setup. Fine. एक object होगा of type list in some memory address A1 and a variable, a name, label basically is pointing to that address. So this is the initial setup. And copy 1, copy 2, copy 3 are 3 ways to create shallow copy of that list. Now what is a shallow copy? उस पे आते हैं. What does shallow copy mean? So this piece of code, like there is a copy thing, we are importing it, and then there is an original list which is a list of list. एक बाहर वाला list है, and which is this one, and inside this we are storing some list. So shallow copy by definition क्या कहता है, that whenever you do shallow copy of a list, we create a new list and we keep the references of the inner elements of the list same as the original one. इससे क्या मतलब, for example, if this is the case, so this outer one, let's say it's at address A1, this inner one is at address A2, this inner second inner one is at address A3. When someone makes, and this is a pointer original, and when someone copies it, it creates a new list. Fine. The outer list is created new, and we are, let's say, naming it shallow. Fine. And inside it, the references of the inner elements are kept same. So basically, the outer list address transformed to A4, but the inner one 1 2 are basically the same one which was in the initial original list. Basically, it would be better to write like this, that the first element and the second element are still referencing to the address A1, A2 and A3, right? So this is the shallow copy where the outer list is created new, but the inner elements are still holding on to the reference of the original one. Okay. A mental model, similar kind of mental model is shown over here, like original इनने सिर्फ रेफरेंसेस से दिखाया है. सो बेसिकली ओरिजिनल के अंदर अगर एक रेफ ए है, एक रेफ बी है, एंड रेफ ए पे क्या स्टोर्ड था 1 2, रेफ बी पे क्या स्टोर्ड था 3 4. सो शैलो, दिस वाज द ओरिजिनल. सो शैलो में भी outer list would be created new, and inside that also ref A and ref B will be there, same references. So this is about shallow copy. Now some important points about shallow copy. If your list contains simple values like numbers or string, these copies behave just like true duplicates. So to give you more clarity, what are true duplicates? Basically over here हमने क्या किया, outer list तो हम नया बना रहे हैं, बट इनर लिस्ट हम लोग इन दोनों को फिर से क्रिएट नहीं कर रहे, वी आर जस्ट कीपिंग द सेम रेफरेंसेस. सो इट इज नॉट डुप्लीकेटिंग. ठीक है. और ट्रू डुप्लीकेट से क्या मतलब है उसका, that the inner ones are also created new like the outer one is created. But ऐसा हम लोग shallow copy में करते नहीं. But there is a catch. If your list contains simple numbers like numbers, simple values like numbers or string, then these copies behaves like true duplicate. Now why is so? To explain this, we have to first see what is the difference between shallow copy and deep copy. So basically, if we create an list like this, rather list of list 1 2 and 3 and 4, so this is the original one. Deep may be same list like 1 2 3 and 4. Now अगर एक sequence of operations हम इस पे perform करें, like create a shallow one, shallow copy अगर मैंने create किया और एक deep copy मैंने create किया, ठीक है, उसमें क्या होगा, shallow में outer list नया बनेगा but inner would be still be referencing to this 1 2 and 3 4. deep में क्या होगा, सब कुछ नया बनता है, like if everything is created new, तो 1 2 भी नया बनेगा एंड 3 4 भी नया बनेगा, एंड दे वुड बी इन सम डिफरेंट एड्रेस. मान लो ये ए है और ये ए बी है, तो ये ए सी होगा और ये ए डी होगा. इन सम डिफरेंट एड्रेस इट विल बी क्रिएटेड. पर इसमें अगर ये ए है और ये ए बी है, तो इट वुड बी स्टिल बी ए स्टिल बी ए बी. तो प्रॉब्लम लाइज इन नाउ, अगर if we try to make some changes to shallow का zero का zeroth element, if we are changing it to let's say 10, so इससे क्या होगा, it is referencing to this one, right? So this list, so zeroth one is this list and इसका zero means this element, so we are changing it to 10. So the problem is this change will happen in both the list, the original and as well as the shallow. So post this operation, ओरिजिनल में भी पहला एलिमेंट 10 हो जाएगा और बाकी वैसे के वैसे, और जो शैलो होगा उसमें भी 10 हो जाएगा. मतलब बेसिकली क्योंकि इनर एलिमेंट्स सेम रेफरेंसेस शेयर कर रहे हैं, ये आउटर पार्ट डिफरेंट है दोनों का, outer list are different but inner they are sharing the same reference. So any change you do it to either shallow or original, it will be reflected in both the places. So this is the problem. Deep में ऐसा नहीं होगा. डीप में इफ यू अप्लाई द सेम ऑपरेशन इन डीप, डीप का जीरो को इफ यू डू इट 10, सो ओवर हियर व्हाट हैपेंस इज जो डीप वाला है that list would be just having that change 10 2 and 3 4, ओरिजिनल वाला अभी भी वैसे ही रहेगा, तो ओरिजिनल लिस्ट विल बी स्टेइंग इंटैक्ट जैसे वो पहले था. सो दिस इज द डिफरेंस. अब इसमें ये चीज़ क्या कह रहा है, द पॉइंट विच स्टार्टेड कि इफ योर लिस्ट कंटेन सिंपल वैल्यूज लाइक नंबर्स और स्ट्रिंग दीज कॉपीज बिहेव लाइक ट्रू डुप्लीकेट्स, मतलब डीप कॉपी की तरह बिहेव करता है. नाउ व्हाई इज दैट सो? लेट्स से जो पॉइंट कह रहा है कि हमारे लिस्ट के पास प्रिमिटिव एलिमेंट मतलब सिंपल एलिमेंट्स है लाइक इंटीजर और स्ट्रिंग, तो हमने इंटीजर का एक लिस्ट बना लिया 1 2 3. सो बेसिकली इसमें होता क्या है, दिस 1 इज एन ऑब्जेक्ट, 2 इज एन ऑब्जेक्ट, 3 इज एन ऑब्जेक्ट, राइट? तो लेट्स से 1 एक ऑब्जेक्ट है इनसाइड मेमोरी at some address A1, 2 is an address A2 and 3 is at an address A3 और outer list is at address A4. ठीक है. So how we see it, Python में everything is an object and the names are basically names or label are basically pointers referencing to that memory address. So if we list original, if we write this at original, ठीक है, तो क्या होगा कि ओरिजिनल एक लिस्ट को पॉइंट कर रहा है इन द मेमोरी एड्रेस, ठीक है, एड्स विच इज एट सम एड्रेस A4 एंड जो फर्स्ट एलिमेंट है इट इज पॉइंटिंग टू दिस, जो सेकेंड एलिमेंट है इट इज पॉइंटिंग टू दिस ऑब्जेक्ट, थर्ड इज पॉइंटिंग टू दिस. फाइन. नाउ लेट्स से समवन क्रिएट्स अ शैलो कॉपी, शैलो कॉपी, तो उसमें क्या होगा, सेम उसके जो 3 पॉइंटर्स होंगे, आउटर लिस्ट इज हैविंग सम एड्रेस ए न्यू, बट द रेस्ट ऑफ 3 जो उसके एलिमेंट्स है there they will be still be pointing to this 1, this 2 and this 3. Fine. Now if someone does like shallow of 2 is equals to, let's say someone does 10, किसी ने shallow पर 2 10 कर दिया, so do you think that original list will be changing or not? The catch here is original list नहीं change होगा. Why? Because the pointer which was earlier pointing to this integer object 3 will now change its point to another object inside memory, another integer object inside memory, which is 10. But still the original one, this one, still the original list, its third pointer is still pointing to that same 3. So you got the point कि जब भी the list contains some simple elements like integer, string and all, जिसमें whenever you are changing the values, that simply doesn't mean you are mutating it because these are immutable types. Integer immutable है, तो अगर तुमने थर्ड का वैल्यू चेंज किया विच इज ऑफ टाइप इंट, थर्ड प्लेस पे एक इंटीजर है, यू चेंज इट्स वैल्यू, तो इट्स अ इंटीजर, यू आर नॉट बेसिकली mutating the value, you are creating a new one inside the memory and you're changing the reference. So that is the reason why here the shallow copy acts as a deep copy. So this is the reason behind this point. If your list contains simple values like numbers or strings, these copies behaves like true duplicates. And इसी के साथ ये भी हाईलाइट कर देते हैं लाइक और क्या क्या हो सकते हैं, नंबर्स हो सकते हैं, स्ट्रिंग्स हो सकते हैं, टपल्स एज वेल, टपल्स भी इम्यूटेबल. सो एनी, so if inside the list values are anything which is not mutable and if you are changing the values, that means तुम नया क्रिएट कर रहे हो, राइट? तुम उस चीज को म्यूटेट नहीं कर रहे हो, सो इट्स नॉट शेयरिंग द रेफरेंस एनी मोर. सेम रेफरेंस अब नहीं शेयर कर रहे हैं वो दोनों, ओरिजिनल और जो शैलो कॉपी. सो दैट इज वाई वो ट्रू डुप्लीकेट्स के जैसे एक्ट करेंगे, because they can't be modified in place. और लिस्ट डिक्शनरीज सेट mutable है, yes. Safe to shallow copy, no. Both share the same inner objects, right? मतलब list, dictionary or sets, these are mutable, right? So now when you're changing values, you're changing them in the inner, in place, right? So उसमें अगर तुम ऐसा करोगे तो deep और shallow में difference आएगा. But if you're doing it with some simple values like numbers, strings or tuples, then they just act like true duplicates. I hope I made it clear. uh, so number, string, boolean, tuples are immutable in Python. That means you can't change them in place. Any change actually creates a new object. So even though the copies share references, you can't accidentally change the shared object. Yeah. So वही चीज जो मैंने समझाया है, it is written over here. And there is an example as well. That original is 1, 2, 3. Then you created a copy. Then you created a copy, and then you made change to the copy. So do you think the original will change? Obviously not, which I explained. Okay. But if your list contains nested list or mutable objects, then all the copies will still share those inner objects. Yeah, that's the core reason, that if the inner elements are mutable, to shallow or deep, there is a difference. But if it's immutable, this means you cannot share the same references anymore. Then there is a then the shallow starts to behave like as it's a true duplicate. Fine. So another example where okay, this is a mutable one because it's a list of list, and when we doesn't do anything to the copy one, it also changes. Like we did copy of 0, copy 1 of 0, which is 1, 2, and then we did append 99. So ये 99 original वाले में भी आ जाएगा. So this is everything about shallow copy. Now moving to deep copy. Deep copy मैंने पहले ही explain कर दिया है while I was doing a analysis between shallow and deep. तो उसी का एक बार revision कर लेते हैं. So basically, by definition, a deep copy makes completely independent clone of an object, including all nested objects inside it. So changes in one copy don't affect the other, even deep down. So यहाँ पर कोई भी references share नहीं हो रहे होंगे. So because of which shallow copy में वो एक में change करने से दूसरे में reflect हो रहा था. Over here, no such problem will occur because we are going to create everything new. Like if we see this example, it's a list of list. So basically, whenever we create the deep copy using the syntax, outer list भी नया बन रहा होगा in some new address, and the inner lists are also created in some another new address, a new dash a double dash new, which is different from the original one. ठीक है. मेमोरी पिक्चर के लिए यहाँ पर दिखाया गया है कि like 1, 2 if we assume कि reference A पे थे और 3, 4 reference B पे थे, then in the deep copy we are seeing कि reference C पे है 1, 2 और reference D पे है 3, 4. So it's being created all new. So after this, अगर deep copy में अगर हम लोग कुछ भी append कर रहे हैं, so basically like this was a list 1, 2 and 3, 4. So as per this syntax, it's telling deep. First of all, this is the original one. Let's say this is the original and this is the deep, which is having the same values but not the same reference क्योंकि ये नया बना है. ठीक है. तो every address is new. Now if we do deep of 0 dot append 99, deep of 0 is basically this list 1, 2, and it's telling that we are appending 99 to it. तो deep में 1 2 और 99 आ जाएगा, 3 4 as it is, and the list will be as it is, and it would just be in the deep list. Original is still intact जैसा वो था, because these are both independent of each other now. So original remains unchanged, deep is modified. So that was it about shallow copy and deep copy.